All right, so this is the 6.5 and 6.6 quiz review. We did a little bit of everything yesterday, so today we're going to finish and do the questions that we didn't get to do. So let's take a look at number 3. Our goal is to change 9 to be in terms of either 3 or 6 by either multiplying 3 or 6, dividing, or using exponents. How could I change 9 to just be in terms of 3 or 6? Awesome, so we're going to change 9, you're saying, to be 3 times 3. And then, how can we break up the log with multiplication?
Oh, I don't know that. I did differently.
What goes with multiplication? Addition. So log base 5, 3 plus log base 5, 3. And then log base 5 of 3 is 0.683 plus 0.683. 1.366. Awesome. On the quiz, it'll be specific on what to round to. So just make sure you read the directions on what to round. A lot of people made that mistake with the tests. The questions said round to 3 decimal places, and they only gave me 1. So just be careful. Read the instructions. You could have split this up as log base 5 of 3 squared, and then move the 2 to the front, and you would have gotten the same answer. So either way would work. Any questions here? All right, let's look at 5. Here we are expanding the log. So we got a couple things going on here. What do you want to do first? It's division, so what goes with division? Subtraction. So log base 6 of 5x squared minus what? Log base 6 of y to the 3rd power. Awesome. Every time you break it apart, each one needs its own log. Is there anywhere else I need to break it apart here? 5 and x squared are being multiplied. What goes with multiplication? Thank you. Addition. So let's break this apart. Log base 6 of 5. What would come next? Plus log base 6 of x squared minus log base 6 of y to the 3rd power. Anything else I need to do? The exponents. Where do the exponents go? Just in front of that log. So it goes in front of the log that it's with. So I have log base 6 of 5 plus 2 log base 6 of x minus 3 log base 6 of y. All right, let's look at 6. All right, what can we do first for 6? I can change the square root to be the 1/2 power because we know that the square root of x is the same thing as saying x to the 1/2 power. Which two numbers are under, or which two variables or terms are under the square root, the radical? The x and the y. So I'm going to split that up because they're two separate things. So I have x to the 1/2 power and y to the 1/2 power. They both get that 1/2 because they're both under the radical. Now I'm multiplying the 6, the x to the 1/2 power, and the y. What goes with multiplication? Addition. So how would I write my answer? Or the next step. Let's just do the next step. How would I break this apart with addition? What do I start with? So log base 8 of 6 plus log base 8 of x to the 1/2 power plus log base 8 of y to the 1/2 power. Every time we break it apart, each term needs its own log. And then last step, what do I do with the exponents? Bring it in front of the log that it's attached to. So I have log base 8 of 6 plus 1/2 log base 8 of x plus 1/2 log base 8 of y. So this would be our final answer. All right, let's take a look at number 8. Here we're condensing the log. So when we condense, we're just making it a single log. What goes with subtraction? Division. So I have log base 7 of what? Of 3 over 5. Perfect. We just divide the two things that we were taking the log of. So it condenses down to just one log, and we divide 3 and 5. So it's always the first one's on top, divided by the second one. Any questions here? All right, I'm going to jump down to 10 on the bottom because it continues with condensing. How could I condense here? What should I do first? Awesome. I got to bring my coefficients to be exponents. So when you're condensing, you're doing things in the opposite order. So we're bringing the coefficients out front to be the exponents. So we have ln of 4 squared plus the ln of x to the 5th power plus the ln of y cubed. Now to condense more, what goes with addition? Multiplication. So how would I write the next step? Of 4 squared. You could change it to 16 if you want. You could leave it 4 squared. Oh. X to the 5th, y to the 3rd. Perfect. So you're condensing it down to a single log. So when you condense it, you get rid of the other ones. So we just multiply everything we have here. You could write your answer as ln of 16 x to the 5th, y to the 3rd. That would be fine too. Or you could put it in parentheses if you want to. Either way is fine. Any questions here? All right, let's do number 9. What should I do first here? Move the coefficient to be an exponent. So I have log base 8 of 5 plus log base 8 of x to the 1/4 power. What could I do next? Perfect. So I combine them with multiplication since I'm adding, so log base 8 of 5x to the 1/4 power. You could write it like log base 8 of 5 and then the 4th root of x. So you could change it to be a radical. Either way is fine. If you want to just leave it as the exponent, that's okay. Let's go back to 14. We're doing our change of base formula here. Bella, what's our change of base formula? George, want to help her out?
Oh, log 16? That would be log 10 over log 6.
Perfect. Log of 10 over log of 6. What would I do next? We got to divide it. We got to put it in the calculator. So we put it in the calculator. Log of 10 divided by log of 6. Make sure you know how to use your own calculator. You got 1.2850. Does the 0 mean that we round up or stay the same? Stays the same. Bless you. So that would be our answer. All right, so let's take a look at number 1. So we said yesterday, if we have the same base, we can cancel out our bases and set the exponents equal to each other. So here we have x minus 7 is equal to 2x plus 3. What can I do next? Combine like terms. So subtract the x and we can subtract the 3. So we get negative 10 is equal to x. So that would be our answer. These questions just get a little bit more tricky when it doesn't give you the same base, but we could make it have the same base. So we talked about this one yesterday. I'm just going to erase it so we can start this one again. So how can I make these have the same base? Make the 9 3 to what power? 3 to the 2nd power. So we're not changing the value of 9. We're just changing the way that it looks. So So I have to change 9 to be 3 squared. If you change the 3 to be 3 squared, you're changing the value of the 3. So you can't do that one. You have to change the 9 to be 3 squared. Because again, it doesn't change the value, it just changes the way that it looks. So 3 to the power of x plus 1 is equal to 3 squared. What do I do with the exponent that was already there? Just times it by the new exponent. They just get multiplied together. When my bases are the same, what can I do? Cancel them out, and then we just set the exponents equal to each other. So x plus 1 is equal to 2. Awesome. We got to distribute, so it's 2x minus 6. What do I do next? And? Add 6. So 7 is equal to x. Awesome. There's one in the notes that I think it was, maybe it was in the homework. Like, let's say 49 to the power of x is equal to 1 over 7 to the power of x plus 2. So this is an extra practice one. I don't know if it'll work out to be a nice number, but we'll see. What would I need to do here? So if they both have exponents, we need to get them to have the same base. How could I get these to have the same base? I can do the 1 over 7 to be, well, I can't change the value of it. Whatever I make it, it has to be 7 to what power? 7 to what power would give me 1 over 7? To the negative 1 power. So I couldn't make it to the power of negative 2 because then you're changing the value. Like, we don't only want to make them look the same, but we have to keep the value the same. So I'm going to change the 1 over 7 to be 7 to the power of negative 1 because it doesn't change the value. So 7 to the power of negative 1 times x plus 2 is equal to, now how can I change 49 to be the base of 7? 7 squared. Because 49 is the same as 7 squared. We're not changing the value, we're just changing the way that it looks. And then I can't forget the x that was already in the exponent. We just multiply them together. So now when my bases are the same, what can I do? Cancel them out and set the exponents equal to each other. So 2x is equal to negative 1x plus 2. What would I do next? Distribute the negative 1, so 2x is equal to negative x minus 2. Then what? Combine like terms. We can add the x. So 3x is equal to negative 2. And then what? Divide the 3, so we'll get a fraction, which is fine. We can just leave it as negative 2 over 3. So there's a question like this in the notes. Also, there was a couple like this in the homework. I just wanted to practice just in case we may see something like this on the quiz. So we did 4 together in class. Let's look at 6. So there was one like 6 in the notes too. What do I need to do first here? Move the 7. So we want to get the term with the exponent all by itself first. So I'm going to add 7 to the other side. So I have 4 times e to the power of 2x is equal to 8. What do I do next? Divide by 4. So e to the power of 2x is equal to 2. Then what do I do? How do I get that e to cancel out? I ln both sides. Because ln cancels out with the e. Remember, ln is the same thing as saying log base e. So if we can't get our bases to be the same like we did in the last question, we have to take the log of both sides, which our base is e, so we could just take the ln of both sides here. Because ln and e will cancel, so I'm left with 2x is equal to ln of 2. Awesome, let's put it in the calculator. ln of 2 would be 0.693, and then we divide by 2. So divide by 2. So you should get x is equal to 0.3465. Do we round up or stay the same?
0.347, better round that.
We got to round it up, so 0.347. Bless you. So don't forget, when you can't get the bases to be the same, so for like questions 4 and 6, when you can't get the bases to be the same, you have to use logs. Bless you. Let's look at number 10. What could I do for number 10? What do I do if I have a log is equal to a log? They cancel. So we can just cancel out the log. So same thing I did with number 8. If you have an ln is equal to an ln, you cancel out the ln's or cancel out the logs and set whatever you were taking the log of equal to each other. So 4x plus 1 is equal to 25. Subtract 1 on both sides to move it over. So 4x is equal to 24. Divide by 4. So what does x equal? X is equal to 6. Awesome. Any questions there? We started 12 yesterday, but I'm going to erase it so we can do it again. So let's take a look at 12. Now when we only have one log on one side, we can't just cancel out the logs. What do I need to do? So why 10? Because it's log base 10. Remember, when our little base isn't written, it's implied that it's a 10. So we make the big base whatever the little base is to cancel out. Because if we have logs, we have to use exponents to get it to cancel. If we have exponents, we use logs. So I'm going to make the big base 10 on both sides. So 10 to the power of log base 10 cancels. So we're left with 10x minus 7. And what's that equal to? 10 to the power of 3, which is 1,000. Be super careful here. You're not multiplying. This is 10 to the third power. It's an exponent. We made the big base 10. So that would be 1,000. What do I do next? Add 7. So we get 10x is equal to 1,007. Perfect. 1,007 divided by 10 would be 100.7. So when you only have one log, you got to use exponents to get it to cancel. So we did 14 in class yesterday. 16 is one of those that don't factor, so you just leave it. Let's look at 10. So what do I need to do to get rid of that log for number 10? Make the big base 2. Why 2? Because it's log base 2. So whatever the little base is, that's what we have to make the big base. So 2 to the power of log base 2 cancels. Because it's the same basis, so they cancel out. So I'm left with 3x plus 12 is equal to what? 2 to the fourth power, which is 16. So this isn't 2 times 4, it is 2 to the fourth power. And 2 to the fourth power is 16. What do I do next to solve? Subtract 12. So 3x is equal to 4. And then what? Divide by 3. So x equals 4 over 3. Perfect. All right, let's look at 12. So I have a log on just one side. How do I get rid of that? How do I cancel out the log? Make the big base 2. Why are we making the big base 2? because the little base is 2, so it'll cancel out. So I have to make the big base 2 on both sides. So 2 to the power of log base 2 cancels. So I'm left with x squared minus 2x plus 1 is equal to 2 to the 4th power. What's 2 to the 4th power? 16. How did you know we had to factor? Because there's an x squared and an x. We can't combine like terms. We have to factor. So when we factor, we need this to be equal to what? 0. So I have to move the 16 to the other side. So I'm going to subtract 16. So I get x squared minus 2x. What's 1 minus 16? Negative 15 is equal to 0. I'm going to move it on the side over here so we have more room. So x squared minus 2x minus 15 is equal to 0. All right. Do we have two factors of negative 15 that add to negative 2? Negative 5 and 3. Perfect. So x minus 5 and x plus 3 is equal to 0. Awesome. Set them both equal to 0. So x is equal to 5 and x is equal to negative 3. When I get two answers, what do I have to do? Check your work. So we have to check them by plugging it into the x's here in the original equation in our log. Because what can a log not be? Negative. So we can't take the log of a negative, so we got to plug it in to make it positive. So first let's plug in 5. So I have 5 squared plus 2 times 5, or minus 2 times 5, plus 1. So 25 minus 10 plus 1 would be 15 plus 1, which is 16. Can I take the log of 16? Yes, so 5 works. Let's try negative 3. So again, we're plugging negative 3 into our equation here. So I have negative 3 squared minus 2 times negative 3 plus 1. So 9 plus 6 plus 1 would be 16. Does negative 3 work? Can I take the log of 16? Yeah. So they're both answers. So this is one of those cases where both of them work. So I told you before, both answers can work. It's not always just the negative that doesn't work. And this is one of those cases. So we got 2 answers here. All right, let's do 14. So 14 is one of those that we know that don't factor, but it's okay. We're going to work up until we get to the factoring part. What would I have to do first here? If I have 2 ln's or 2 logs on one side, what do I need to do? Condense it to 1 log. Condense to 1 ln, we could say. How do I condense when I'm adding? Multiply. So the ln of x times x minus 2 is equal to 5. What can we do next? I can distribute. So the ln of x squared minus 2x is equal to 5. How can I get rid of that ln? Make the big base ye. Because ln is log base e. So we make the big base the same as the little base. So I raise both sides with our big base e. So e and the ln cancel. I'm going to rewrite it over here so you have more room. So I'm left with x squared minus 2x is equal to e to the 5th power. What do I do next? I need to move the e how? Subtract. To move it to the other side, so I'm subtracting e to the 5th power, so I get x squared minus 2x minus e to the 5th power is equal to 0. We can't factor this, so we can just leave it. Everything on the quiz will factor, so you can keep going, but for this question, to know that you cancel it out using E. So that's why we did it up to here. But from here, you would factor, you just can't factor this one. Let's look at 16. What do I do when I have two logs? Condense it to one log. How do I condense with multiplication? Or with addition? Multiplication. So log base 3 of negative x times x plus 8 is equal to 2. What can I do next? I can distribute. That works. So log base 3 of negative x squared minus 8x is equal to 2. What can we do next? Make the big base 3, but we have to do it on both sides. So 3 to the power of log base 3 cancels, so we're left with negative x squared minus 8x is equal to what? 3 to the power of 2, which is 9. So be careful, this is 3 squared, not multiplication here. That 2 became an exponent. 3 is the big base, so we get 9. What can I do next? Move the 9 to the other side because we know we have an x squared and an x, so we're going to have to factor. All right, to factor, what should we do first here? Divide by -1. We like it when that x squared is a positive 1 as our coefficient. So if we can take out the GCF, take out the GCF. Or if you can divide out a negative, divide out the negative. It will help you so much when factoring. That way you don't have to worry about the signs. So x squared plus 8x plus 9 is equal to 0. Now, do we have two factors of 9 that add to 8? What's 9 times -1? -9, not +9. So here it doesn't factor. So that's why I highlighted this one too, because it doesn't factor. You can just leave it here. Again, everything on the quiz will factor, so you won't have to worry about it. When we get two answers, what do we need to do? Check your work. So with the log equations, so when solving logs, you'll have 3 types. So one is when you get a log is equal to a log. What happens here? What would I do to solve? Cancel out the logs. The next type is, let's say we had just one log, so log base 5 is equal to a number. What would I do here? Make the big base 5. We make the big base whatever the little base is. We got to do it on both sides. And then the third case we have is if we have two logs on one side. So let's say we had log base 2 plus log base 2 is equal to 4. What would I need to do here? Awesome. Condense to one log. And then we do the same thing that we did in the second case where we just make the big base whatever our little base is to get it to cancel out. So these are the 3 cases that you'll see when solving logs. So looking at step 2, it kind of relates to that. Let's say we had ln is equal to 2. So ln of something is equal to 2. How do I get that ln to cancel? To go away. Make the big base e.